Why the engine knock happened is discussed in this video. During normal combustion, the air-fuel mixture in the combustion chamber starts burning from the spark plug as soon as the sparking takes place. The mixture burns smoothly from beginning to end, providing an even and powerful thrust to the piston. The pressure inside the cylinder increases evenly. As soon as the sparking takes place, a wall of flame spreads out in all directions from the spark. It travels rapidly outward through the mixture until all the charge is burned. Definition: under certain conditions, part of the air-fuel mixture explodes before the flame wall reaches it. The temperature of the last part of the mixture increases as the flame progresses. If the temperature reaches the critical point, the last part of the mixture will explode before the flame reaches it. This causes a sudden increase in pressure which imposes a sudden heavy load on the piston that is almost like a hammer blow. Knocking and detonation. It should be noted that knocking and detonation are synonymous terms with the same meaning. Detonation is the name given to the sudden and violent knocking experienced inside the engine cylinder. Detonation is not pre-ignition. If the detonation is allowed to continue for a long time, it may overheat the cylinder and spark plug so as to ignite the charge even before the sparking. This will cause pre-ignition. Thus, detonation follows the spark while pre-ignition precedes it. Factors affecting knocking or detonation. 1. Compression ratio. A higher compression ratio increases the tendency for knocking. With a higher compression ratio, the mixture at TDC is more highly compressed and is at a higher initial temperature. With higher initial temperature and pressure, the temperature at which detonation occurs is reached sooner. Thus, the higher compression engines have a greater tendency to knock. 2. Cool mixtures. Cool mixtures have less tendency to knock than hot mixtures. Moisture in the air taken in by the carburetor tends to lower the temperature and reduces a greater tendency to knock. 3. Surface ignition and pre-ignition. This type of ignition seriously affects knocking. Surface ignition can originate from hot spots in the combustion chamber, such as on a hot exhaust valve or spark plug, or form combustion chamber deposits. Pre-ignition of the fuel takes place before the spark occurs from the spark plug. 4. Additives. Additives in the gasoline, like tetraethyl lead, reduce the tendency to knock. 5. Chamber design. The shape of the combustion chamber has a significant effect on the tendency of the engine to knock. Due to the proper design of the combustion chamber, the air and fuel mix properly in the cylinder for normal combustion. 6. Operating conditions. Many operating conditions in an engine affect knocking. For example, higher air temperatures increase the tendency to knock, and higher humidity and higher altitudes, or lower air density, reduce the tendency to knock. Scale information in the cooling system, clogged fuel lines, improper ignition timing, and engine deposits all increase the knocking tendency of the engine. 7. Fuel. The type of engine fuel has a considerable effect on knocking. Fuels like alcohol and benzyl do not cause knocking, but they give a higher rate of consumption because of lower calorific values as compared to that of petrol. 8. Spark plug. The position of the spark plug in the combustion chamber greatly affects knocking. Centrally placed spark plug proves quite useful. If it is placed outside the combustion chamber, the flame has to travel a longer distance to reach the detonation zone.